Global warming. Abstract. Climate change includes both global warming driven by human emissions of greenhouse gases, and the resulting large-scale shifts in weather patterns. Though there have been previous periods of climatic change, since the mid-20th century, humans have had unprecedented impact on Earth's climate system and caused change on a global scale. The largest driver of warming is the emission of greenhouse gases, of which more than 90% are carbon dioxide, CO2, and methane. Fossil fuel burning, coal, oil, and gas, for energy consumption is the main source of these emissions, with additional contributions from agriculture, deforestation, and industrial processes. The human cause of climate change is not disputed by any scientific body of national or international standing. Temperature rise is accelerated or tempered by climate feedbacks, such as loss of sunlight reflecting snow and ice cover, increased water vapor, a greenhouse gas itself, and changes to land and ocean carbon sinks. Temperature rise on land is about twice the global average increase, leading to desert expansion and more common heat waves and wildfires. Increasing rates of evaporation cause more intense storms and weather extremes. Temperature rise is amplified in the Arctic, where it has contributed to melting permafrost, glacial retreat and sea ice loss. Additional warming also increases the risk of triggering critical thresholds called tipping points. Impacts on ecosystems include the relocation or extinction of many species as their environment changes, most immediately in coral reefs, mountains, and the Arctic. Climate change threatens food security and access to water, leads to economic losses, and is projected to increase displacement of people. It further magnifies risks of flooding, infectious diseases and extreme heat, with the World Health Organization calling climate change the greatest threat to global health in the 21st century. Even if efforts to minimize future warming are successful, some effects will continue for centuries, including rising sea levels, rising ocean temperatures, and ocean acidification. Storm intensification. Bangladesh after Cyclone Sidr is an example of catastrophic flooding from increased rainfall. Ecological collapse. Bleaching has damaged the Great Barrier Reef and threatens reefs worldwide. Environmental migration. Sparser rainfall leads to desertification that harms agriculture and can displace populations. Shown, Telly, Mali. Heat wave intensification. Events like the June 2019 European heat wave are becoming more common. Tidal flooding. Sea level rise increases flooding in low-lying coastal regions. Shown, Venice, Italy. Arctic warming. Permafrost thaws undermine infrastructure and release methane, a greenhouse gas. Pest propagation. Mild winters allow more pine beetles to survive to kill large swaths of forest. Agricultural changes. Droughts, rising temperatures, and extreme weather negatively impact agriculture. Shown, Texas, U.S. Extreme weather. Drought and high temperatures worsened the 2020 bushfires in Australia. Habitat destruction. Many Arctic animals rely on sea ice, which has been disappearing in a warming Arctic. Many of these impacts are already felt at the current level of warming, which is about 1.1 C. The Intergovernmental Panel on Climate Change, IPCC, has issued a series of reports that project significant increases in these impacts as warming continues to 1.5 C and beyond. Responding to climate change involves mitigation and adaptation. Mitigation limiting climate change consists of reducing greenhouse gas emissions and removing them from the atmosphere. Methods include the development and deployment of low-carbon energy sources such as wind and solar, a phase-out of coal, enhanced energy efficiency, reforestation, and forest preservation. Adaptation consists of adjusting to actual or expected climate, such as through improved coastline protection, better disaster management, and the development of more resistant crops. Adaptation alone cannot avert the risk of severe, widespread and irreversible impacts. Under the Paris Agreement, nations agreed to keep warming well under 2.0 C through mitigation efforts. However, under those pledges, global warming would reach about 2.8 C by the end of the century, and current policies will result in about 3.0 C of warming. Limiting warming to 1.5 C would require having emissions by 2030, then reaching near zero emissions by 2050. This project compresses information gathered from Wikipedia in video format. Why should I watch it? Studies prove that reading while listening improves comprehension, increases speed as well as expands vocabulary and enhances fluency. Provide your feedback on the comments section. Support the channel by subscribing and liking the video. Thanks.